Thanks very much. So as Finn said, I'm acting as window dressing really for Matt's talk. And we're talking here about population attributable fractions in the context of TB. And I'm sure everybody is well aware of this, but just so we're all on the same page about what we're talking about, really we're thinking about these as a metric to help inform prioritization, to get a sense quantitatively of which risk factors may be contributing most to TB. And for a couple of years, WHO have been publishing PAF estimates for a number of risk factors for HIV, and they do so on a country-by-country basis, so that countries can look at what PAFs are for different conditions in for TB from different risk factors in their setting to help inform decision making there. Next, please. So again, just so you know, we all have this at the back of our minds, or it's the kind of thing that I like to have in my head, so I know what I'm thinking about. So the PAF is defined basically with reference to the counterfactual. So you're thinking about the burden of, in this case, TB, some condition, either as incidence or prevalence, as it is now, which is the subscript zeros. I'm thinking about what fraction of that would change under a counterfactual scenario, which is the subscript 1. So typically, if you're thinking about some single risk factor, which has a prevalence of little p and a risk ratio r, then you can go about thinking about this in terms of how much lower is your counterfactual burden than your current burden. And if you look at that on the denominator there, it's probably easiest to think about. You've got the prevalence of the risk factor times the risk ratio, and then contribution from the 1 minus p of the population who don't have the risk ratio applied. And in the numerator, you can either think about zeroing the prevalence of your risk factor, in which case the numerator is 1, or you can think about setting the risk associated with that risk factor to 1. So waving a magic wand and not getting rid of the risk factor, but making it so that it doesn't increase your risk of the condition. So either way, you get this 1 over blah, blah, blah term. And if you plug that back up into the formula for PAF to get a sense of how much, what fraction you've removed, you get this formula at the bottom, which is most commonly the way it's presented. And I think this has the name Levin attached to it. And it's basically saying that the PAF on an odds scale is equal to the product of the excess risk and the prevalence of the risk factor in the population. So if either of those things is 0, so your risk ratio is 1 or your risk factor isn't there, then you don't have a PAF going on. Next, please. So there are, lots of complications and caveats of PAFs, as you would expect for something that's basically a sort of abstract construct. So the first one perhaps to think about is that it's not the same as a vertible burden. So, for example, in the case of smoking, if you waved your magic wand around the world and made it so that nobody smoked anymore, that wouldn't mean that the incidence of lung cancer due to smoking would suddenly go away, because there'd be lots of people who had smoked and still had the damage accumulated from that risk factor, even with the risk factor no longer being present. So that sort of example might make you think, well, actually, maybe what we need to think about with PAFs is to think about it as a kind of a long-term equilibrium thing, so that there's time for any changes you make to kind of manifest themselves. But I'm not sure that necessarily helps always either, because obviously in the long term, other things are changing, and also because there are other complications that associate particularly with infectious diseases, where you've got a causal feedback loop lurking in the system. So if you wanted to think about, equilibrium prevalence for an infectious disease, you could imagine a situation where you're just above sort of endemicity thresholds, and you tweak a risk factor that brings you below that threshold, so that in the long run, actually your equilibrium goes away to zero. And then you would say, great, well, we've got a 100% PAF for this risk factor. And of course, you might end up with a 100% risk PAF for several risk factors if they could have nudged you the other side of that threshold. So not sure that kind of equilibrium way of thinking is necessarily helpful, and also highlighting that PAFs are potentially limited in their application to infectious diseases. So people have thought about various things here, and my background isn't in epidemiology, so I won't pretend to know more about these things than I do, but people have tried to define transmission paths, and they've also looked into more R-based paths. And then on the more statistical side, people have thought about issues around causality when using observational data to inform paths, and thinking about paths associated with pathways. So there's a variety of complications, but we're not going to be thinking about those. We're going to focus on one of them that I'll introduce in a minute. But just to say from this background, that the way I'm thinking about paths is that they're really a kind of instantaneous measure for quantifying risk factor contributions. So if you think about something instantaneously, then the caveats with respect to infectious diseases are more about how much they tell you about long-term effects rather than interpretation. So in other words, if you think about your magic wand and waving away your risk factor, the change from one moment to the next is still okay for an infectious disease, even if but you need to bear in mind that will not reflect over multiple generations when you get feedback. Next, please. So really, for us, when we started thinking about this in the context of TB and BMI, we were trying to do the best that we could in terms of using data and thinking about BMI as a continuous risk factor, so that we can really get as much granularity in making the relationship between our outcome of interest and any changes that might occur at the population level. And actually, continuous risk factors you can deal with within this framework. Basically, all the same formula that I kind of waved under your noses earlier still apply, but with multiple, chopped up risk factors and associated risk ratios. Now, in fact, the more you think about this, the more you start to realize that many things that you think about as being binary risk factors are actually continuous risk factors in reality. So it may be convenient to chop them up, but many of them function in a continuous way. So smoking is an example where, in fact, it's not just yes or no, but actually how much do you smoke, and maybe air pollution is even more continuous than smoking. So the moment you think about risk factors being continuous, you've got more choice in how you think about, there's more flexibility there in defining a counterfactual scenario for the population in order to make a comparison and define a path. And for BMI in particular, there's an additional problem that makes this especially acute, and that's that there isn't a kind of notion of a minimum. So for things like smoking, you can say, okay, no smoking, or some other binary risk factor. For BMI, you can't say that people have no BMI or that they have infinite BMI, because it just doesn't make sense. So that means you're forced with trying to make a choice of what would be a reasonable counterfactual for BMI to use in defining a path, and it introduces necessarily some amount of subjectivity. Next, please. So the last slide before I hand over to Matt is just to comment on some thinking that is contained in this essay from more than 20 years ago now that was coming out of the Global Burden of Disease study. And I can't remember the exact title, but it's something along the lines of lessons learned from the Global Burden of Disease study and thinking about PAFs for continuous risk factors. And it's quite an interesting piece. I think once you, reflect back on it, I think actually many of the concepts are not restricted just to continuous PAFs, in fact. So they talk about different ways you can motivate constructions of counterfactuals in order to define PAFs. And they're really thinking about continuous risk factors, although, as I say, I think this goes a bit beyond that. So their category 1 counterfactual, they call a theoretical minimum risk. So that's the equivalent of setting P equals 0 or eliminating the risk factor. And as I say, for us, this one isn't an option because there isn't a theoretical minimum risk in a clean-cut way for BMI. They then think about plausible minimum risk, which is basically thinking about what you could do using going absolutely to the max on real interventions. So things that exist, but using them in potentially unrealistic ways in terms of their coverage and combinations. And then their third category, the feasible minimum risk counterfactual, is thinking about what could you achieve with kind of schedules or combinations, rollouts that are, could be doable in the real world, but only if resource was not an obstacle. And then lastly, they think about a sort of cost-effective minimum risk counterfactual, where you restrict yourself only to rolling out interventions which are cost-effective in whatever settings. Just to note that, of course, you can think about counterfactual or risk functions in all these cases as well, but you face the same problems, really. You just kind of shifted the onus into a different part of the calculation. But I thought, personally, when I read this, I thought it was thought-provoking and useful because as a modeler, we're always thinking about, well, not always, but very often thinking about counterfactuals for modeling the impacts of interventions, and not infrequently interventions that haven't actually been used in the real world, where we don't have the data to inform kind of defined intervention level and standard of care level. So I think some of these considerations are useful beyond just thinking about PAFs to thinking about how we consider defining scenarios in modeling. But at this point, I'll hand over to Matt to get a bit more specific about the exercise that that we're using to illustrate some of these points.
Great, thanks, Pete. So to illustrate some of these issues with PAFs, nutrition is quite a good example, and especially for TB, nutritional status is a useful example, and there are a few reasons for that. Obviously, one is that historically, undernutrition has had the largest PAF in most of the old, I think in all of the old TB reports, and people who are familiar with the kind of technical details of those old calculations will know that PAF was based on a 2009 systematic review showing this inverse relationship between BMI and TB. But of course, in recent years, nutritional status for TB has garnered lots of interest, partly because of the RATIONS trial and because of a body of research on nutrition and TB. And then a couple of years ago, WHO changed their estimates, changed their methodology, and calculated a very different PAF to the one they had done previously, which kind of piques interest. So we kind of came at this from the approach of, well, nutrition is important for TB. We need to refine our estimates to really understand how much TB we think could be attributable to undernutrition. So the first part of this, which I won't go into too much detail on, was a systematic review that we did to update the continuous estimates of how TB risk changes across the BMI range. We did a review of the literature. We included 43 prospective cohort studies which measure BMI at baseline and basically follow people up over several years with incident TB as the outcome. And you can see the geographical variability in studies. Overall, the 43 cohorts included in the review included over 26 million people. Most of those people were in the Western Pacific region, so there were some really large prospective record linkage studies done in Korea, for example. There was relatively less participation from the African region and the Southeast Asian region, which is quite important because those areas have a higher prevalence of undernutrition. But overall, there's inclusion from across the world in this new review. And just to briefly go over the methods, because I think it's just quite nice to highlight also from a modeling perspective. So we did a dose response meta-analysis in this review. So this is how the data are presented in each of the studies. So each study will present BMI categories, which are recorded at baseline, and then they present a relative risk or a hazard ratio or an incident rate ratio of TB associated with being in that BMI category compared to a reference category. And mostly the reference categories are normal weight. So you'll have a relative risk of being underweight compared to normal weight, overweight compared to normal weight, and so on. So we took this data and we took the parameters for BMI in the study population, the mean and the standard deviation. And we basically fit a distribution, an entire BMI distribution for each study. And then basically to account for some of the uncertainty in BMI, rather than just using categories, and using the midpoint of these categories, we did a resampling procedure to estimate a kind of dose for each BMI category. And that's the value that you see in the red. And that value then corresponds to each of these relative risk values. And those are the parameters that then go into these one-stage dose response meta-analyses. And we fit three different types of model for these meta-analyses: a linear model for comparability with the Lonroth review in 2009, and then a restricted cubic spline model to investigate potential nonlinear relationships. And then finally, based on the shape of the restricted cubic spline model, we fit this bilinear or piecewise linear model. And I'll go through this fairly high level. Essentially, here what you can see is relative risk of TB with reference to a BMI of 25, BMI on the x-axis, and tried to just highlight the different categories with the shadings. And we stratified results by population groups. So we have the general population, people with HIV, and people with diabetes at the bottom. And basically, when we fit the linear models, we got very similar results to the Lonroth 2009 review in terms of the percentage decrease in TB risk per 1 unit increase in BMI. So for the general population, that was nearly 15%. But if we look at the non-linear models, what we found is that the restricted cubic spline models were a better fit for the data. So TB risk was increasing fastest at lower BMI values and then decreasing more gradually at the higher BMI values. And so I think you can see that quite nicely in the general population, and especially for people with HIV. For people with diabetes, the evidence is a bit more uncertain at the higher range of BMI. And then finally, we showed that you could approximate those spline models with a piecewise linear model. And what that gives you then is a percentage decrease in TB risk per unit increase in BMI for a BMI of below 25. So that's the steepest part of the graph. And then another percentage decrease in TB risk per increase in BMI for the higher part of the graph. And the cutoff that we used was 25, which was based basically on model fit. So now that we have an updated estimate of how TB risk changes across the BMI range, we wanted to then use those estimates, combine them with population level estimates of BMI to try to model some of these potential elimination scenarios and generate some potential PAFs based on different counterfactuals. So the way we went about doing this is illustrated in this figure. So I'll just go through it quite slowly. So on the left, we have the kind of input BMI data. So we source data from WHO databases and from NCD Risk, which basically provide estimates of the proportions of people in different BMI categories, in different age and sex groups, and in different countries. And then we fitted gamma distributions to these data for each of these population groups. So an example is shown here in the black. That's basically a fitted BMI distribution data to the proportions. And we did that for, I think the age groups were in 5-year groups for different sexes and across different countries. So we sort of generated thousands of these BMI distributions. And then we started modeling our counterfactual scenarios, and I'll show you these more clearly in the next slide. But the sort of base case scenario that we used is shown here. And what happens in this scenario is that we take everybody with a BMI of under 18.5, which is the cutoff for undernutrition, the one that we often use in TB. And basically, we redistribute them proportionally to the rest of the distribution. So that's shown in the red. The red is the counterfactual distribution. We've basically lopped off this left-hand side of the graph and redistributed them proportionally to everybody else in the distribution. So some of them will move from a BMI of 17 to 20, others will move from a BMI of 17 to 35. And the chance of that is just proportional to the overall distribution in the population. And then we can combine these different distributions, the original BMI distribution and the counterfactual, with our new relative risk function. So the relative risk of TB as a function of BMI using this bilinear model that you can see again here. And in doing so, compute the relative TB reduction in these different age and sex groups. And then finally, on the right-hand side, combine that with WHO data to estimate absolute TB reductions if we were to change these distributions and eliminate undernutrition in different countries and ages and sex groups. So I think this is probably going to be the most interesting, and I'll just go through this quite slowly to try to illustrate what we did. So as Pete was saying, the main challenge with nutritional status that we have is that there is no true theoretical minimum risk. There's no agreed optimum BMI distribution in a study in a population. And so the base case was motivated by a desire for simplicity and also on the basis of comparability with other risk factors and equity, which is the one I've just shown, where we basically take everybody below a certain point and then we redistribute them, as you can see in the middle graph, into the overall distribution proportional to the original. And then we had various different sensitivity analyses. So the first is a scenario where we do the same thing, but instead of redistributing proportionally to the entire distribution, we proportionally redistribute up to a certain cutoff point within a range, and that's the upper limit of that range is defined here as H, and the lower limit is essentially 18.5, the cutoff for undernutrition. So what that is saying is we take everybody who's undernourished and we redistribute them into the normal weight, for want of a better word, category, and you can see how that looks in B3 there. And basically, we're moving down this spectrum of theoretical to plausible. So in the third scenario, we basically shift people over. So we take all the people who are undernourished and we just shift them. And in the final scenario, which is the most plausible end of the spectrum of potential interventions, we take everybody who's undernourished and we sort of do this reflection where the majority of them move from a BMI of under 18.5 to a BMI of just above 18.5. And you can see how that looks in D3. So that's sort of representing a small impact of potential nutritional interventions. We think that of all of these, and this is really the challenge, and we spent many hours discussing what the counterfactual should be for the kind of primary analysis, that the top scenario A is the simplest. And of course, it will depend on the underlying distribution in the population, but it's the simplest and kind of can be argued for on the basis of equity and equivalence with other risk factors, as I'll show you in a moment. So if we look at the results, here you can basically see in the table what we have termed the PAF, because it is sort of functionally equivalent to a PAF in these different intervention scenarios. And basically, overall, the PAFs range between 16 to 24%, so up to a quarter of TB attributable or could be averted by eliminating undernutrition. And the theoretical ones, which are the more extreme intervention scenarios, are all above 20%, and the plausible ones, which represent kind of more modest interventions, more modest changes in population BMI status, are all around or between 16 and 17%. So this is just to touch on something that Pete brought up earlier. This is how we do the actual calculation in these scenarios. We have a counterfactual BMI distribution. So we've got two graphs here. On the top is the relative risk function, so relative risk of TB along the BMI continuum. And then we have the distribution in the population. I think this is just a hypothetical global BMI distribution. And the way we actually do this is we have a counterfactual scenario where we change the distribution and the risk function stays the same. And we can compute the PAF in that way. But as Pete said, we can also do the opposite. We can replicate the same results more simply using back calculated relative risks. So here we have the distribution and that stays the same, but what we're changing is the risk function at the top from the base case scenario where we have kind of an average relative risk in the undernourished group. And basically the counterfactual is bringing that relative risk down so that the undernourished have the same risk of TB as people above a BMI of 18.5. And if we do that and we compute these back calculated relative risks, we get a relative risk of TB associated with undernutrition of 4 if we use those theoretical minimum risk scenarios, the base case scenario where everybody is proportionally redistributed. And in the scenario which was a reflection, I'll just show you that again, scenario D, which is more at the plausible end, the relative risk goes down to around 3. And these are some of the results in a bit more detail from this exercise. So on the left-hand side, you can see basically the geographical impact of eliminating undernutrition under the base case scenario, where we take everybody who's undernourished and redistribute them proportionally to the rest of the population. As you would expect, higher reductions could be achieved in sub-Saharan Africa and Southeast Asia. Essentially, this is a function of the prevalence of undernutrition. In the graph here, the horizontal bar chart here, this is just the absolute numbers in different countries. And again, not surprising to see India at the top. And what we did in the full analysis, which I haven't really gone into too much detail here, is model different cutoffs. So we used the standard less than 18.5 for all undernutrition. And we also looked at what would happen if we eliminated moderate and severe undernutrition, which is typically defined as a BMI of under 17. And that's actually very interesting because this group in purple account for a very small proportion of the global population, around 5%. But our analysis suggests that eliminating that as a risk factor would potentially reduce TB incidence by around 16%, so quite a disproportionate impact. I haven't shown that fully here. And then on the right, we've got the same thing, which is the proportion of global TB incidence we could avert by eliminating undernutrition and moderate severe undernutrition in the purple, just stratified by age and population group. And again, this is really a function of the prevalence of undernutrition and shows that the greatest proportional reductions could be achieved in younger adults and older adults and slightly more in females than males because these groups have got higher prevalence of undernutrition, essentially. Nevertheless, despite higher proportional reductions, the highest absolute reductions could be achieved by reducing undernutrition in men because men account for a much higher number of TB episodes every year. So just to end, we thought it would be useful just to highlight what our current estimates imply. So for those of you who kind of kept up to date with all of the changes recently, In the last two global TB reports, World Health Organization are using a relative risk of 2.0 for the risk of TB associated with undernutrition, instead of the one they used previously, which I think was 3.2, which was derived from Knuth's 2009 review. Now, this 2.0 is derived from the Cochrane review, and it's specifically taken from this 4-study meta-analysis. So basically, we tried to reverse engineer this, if you like, to see what that implicit assumption is in terms of BMI distributions. And what the closest that we could kind of come to is this spike counterfactual scenario, which is basically where we would take everybody with a BMI of under 18.5 and just lift them just above the threshold. So they all have a BMI of between 18.5 and 18.6, which is represented by this big spike on the right-hand side here. And that, if you then do all the computations, would give you a PAF of about 11% and a relative risk of about 2.2. So the kind of implicit assumption of what WHO is currently saying is that by eliminating undernutrition, which is that we would avert 11% of TB. When we say eliminating undernutrition, what we're actually saying is just nudging them up to above the arbitrary cutoff. There are some differences in the evidence base which drive some of the differences between our analysis and the Cochrane. I won't go into too much of the detail on this, but I think it's important to highlight really the first one, which was the kind of analytical approach. So as I said, in the review that we did, we tried to estimate the risk of TB across the entire BMI range, and we did that using these dose response meta-analysis methods. Whilst in the Cochrane review, it's very much a binary comparison of undernutrition versus no undernutrition. And the key there is two things. First of all, that in Cochrane, the reference categories changed a lot. So in some, the reference category was set as 18.5 to 23. In some, it was over 18.5. In some, it was 18.5 to 25. And obviously, if there's a dose-response relationship between BMI and TB, you can envisage how that might impact the results. And that's kind of why I've included this on the right-hand side, which is basically how the data were extracted. So in one of the studies, Lynn, for example, which was the study I showed earlier, in the Cochrane review, they would have just extracted the blue, the 2.28 number for the risk of TB associated with undernutrition. Whilst in our review, we tried to include all of these risk ratios in the dose response meta-analysis and capture that relationship. There are also some differences in how studies were included, which meant that we could include all of Knuth's studies and the Cochrane couldn't. And also the pooling of studies was different. Particularly, we separated out people with HIV, which I think probably did impact the results as well. But this is really the kind of key in when we think about the challenge of how we actually estimate and think about these PAFs for TB. I guess the key message is that we should be consistent across different risk factors, because if for one risk factor we're assuming a scenario where we totally eliminate that risk factor, but for another we're modeling a scenario where we just about change nutritional status, they're not quite the same thing. So, for example, the smoking relative risk estimate is derived from a systematic review comparing the risk of TB in active smokers versus people who never smoked. And so the counterfactual scenario there is this graph on the left-hand side, which is that there's no smoking in the population. And that really corresponds closest to Marianne Lopez's kind of theoretical minimum risk elimination of the risk factor. And we think our base case scenario is probably closest to that, as opposed to those other scenarios that I presented. So in conclusion, hopefully we can we'll take some questions and have a discussion. PAF is a bit more complicated than just putting in a prevalence of a risk factor and a relative risk estimate. There are lots of different ways for estimating PAF, especially and for a continuous variable like nutritional status. Both the prevalence and the risk ratio will depend on the counterfactual scenario that we choose. And I think the work that we've done has shown that these can result in quite large differences in estimates. We think that WHO's current approach is corresponding to an implicit choice of a counterfactual scenario where there's relatively small changes in population nutritional status, and that's fine. That might be a kind of conscious decision and we're fine with that. But I guess the message is that this is in contrast to some of the other risk factors in which they're using a minimum risk, maximal change counterfactual. So if you're using these estimates to guide how you respond to your local TB epidemic, we think that there should be consistency essentially between these different risk factor estimates. And yeah, I guess finally, if PAFs are produced for these comparisons, we believe that the work we've done here can hopefully help to ensure this. So thank you. Finn, I'll hand back to you, or Pete, if you've got anything else to say.
Thank you, Matt and Pete. Very, very interesting. Yeah, a lot to think about there, I think, and definitely a really difficult and tricky task to tackle. Does anyone have any questions? I have Nick. Go for it.
No, if you have a question, you go first.
No, mine was a somewhat provocative question, so I'll let you go first.
Okay. Well, I'm going to cheat and include two questions. So the firstly, fantastic sort of exploration, and kind of in my back of my head, I always thought, oh yeah, there's some nasty bits in PAFs that make them a little bit tricky, but I hadn't really thought through. And so I think this is a very clear description of what those potentially nasty bits are and what happens with them. So the first question might be Finn's provocative one, where if we're talking about eliminating all the disparity or the excess burden associated with nutritional or undernutrition, then why stop at the existing threshold? Why not just eliminate all, go all the way up to obese, and say, well, our hypothetical interventions, we're going to make everyone obese because that's the lowest we can go. So that's one question. And then the other question is, so I have this memory of the global burden of disease being a bit leery about dealing with undernutrition and TB due to the potential for sort of confounding in those different studies that you pulled together. So I was wondering if you could say something about, is that right? I'm not sure if the GBD is looking at undernutrition and TB as their sort of risk factor relationships, but were you concerned about residual confounding in the systematic review? That is, populations that had lower nutrition were also populations with higher levels of exposure to new TB infection. So it could be the exposure that you're, if you see what I mean. Thanks.
Yeah, I'll have a stab at the second one, and maybe Pete come in for the first. So the systematic review point, it's there are two things. First of all, there's the reverse causality question. These were prospective cohort studies. To what extent were we just capturing, are those original studies just capturing undiagnosed TB disease that comes, presented later? And most of the studies tried to address that by basically kind of having a washout period. So they'd recruit people, do a screening test, exclude the co-prevalent TB, and then their incident TB diagnosis kind of start point would be a few months after recruitment. But I don't think that completely excludes the possibility of reverse causality. And if there is reverse causality, that will result in kind of an overestimate of the risk function. And then the residual confounding point and the general kind of causality point, I think, is important because many of the studies, there's huge heterogeneity in what variables were adjusted for. I don't think any of them, apart from maybe Peter Cegielski's one, really use kind of a causal framework to try to estimate a causal relative risk. And if you're adjusting for variables that are actually on the causal pathway between undernutrition and TB, then you're going to underestimate. If you're not adjusting for potential confounders, then you could overestimate. It's hard to kind of make a comment on the magnitude of the potential effects of residual confounding, but for sure, I think that what we really need to do actually, if we're doing more of these prospective cohort studies, because there have been enough, we need to try and do proper kind of causal inference epidemiological methods, I would say. And Pete, do you want to come in on the first bit?
Sure. And just to come in on 2A before moving to 1 about global burden of disease and undernutrition. I'm pretty sure they are including undernutrition in their estimates. I haven't kind of gone into the details to look, but I have seen, things pass by me that have mentioned undernutrition. So I think they are now or about to.
Okay, yeah, this might be I mean, this certainly was a historical thing I was remembering. So okay.
And then in terms of your first one, I mean, we did, as Matt said, we spent quite a lot of time talking about this stuff, and indeed, we had ideas about, can we construct a kind of reference population for the world? But of course, that will include people who are suboptimal. Can we think about particular places that might represent, especially healthy populations? But of course, you start to edge. It's also healthy for what? Because you could say, maybe the US is a great place to use as a reference population because they're sort of higher up the BMI spectrum and lower risk for TB. But of course, for other things, they're not so. But I guess the problem is that there isn't a well-defined place to stop if you're thinking about that. You end up kind of pushing and pushing until everybody's disappearing into a black hole. So yeah, I think, and then at the other end, we used thresholds, I suppose, because they have greater currency and operationally might serve as a definition on which an intervention might be based. But I don't have a great answer, except we talked and didn't have a single best response.
And maybe, Pete, to say that whatever the response is, it's sort of a value judgment. There isn't an obvious one, so we could have chosen any of those changes. It's just a value judgment, I think. Richard, I saw you had your hand next.
Yeah, thank you. And again, thank you to everybody. This is really lovely work. And yeah, like Nick, I think I've been using models and PAFs for 25 years. And I think any point that time it's gone into such lovely detail about thinking through what they actually mean and the intricacies of how they should be or could be calculated. So that's really appreciated. My question, I think, might be the provocative one that I think Finn was going to raise, and I just actually checked to see on the call, and I can see there's nobody from WHO on the call, but we do know this call actually is recorded as well, so I don't want to ask you to say anything that's probably not wise to say. But I was wondering if you could speak to, how the chat with WHO is going, or kind of where you are in that, because presumably, they got our estimate, they came down a lot. They've now got a piece out there which says, there are different ways of looking about this. Do we know what WHO are thinking about this that you can share, or you'd prefer not to, just to keep it healthy?
Well, I can say that WHO have a number of considerations that they have to bear in mind in producing estimates. This particular set of estimates are relatively new and are designed to try to gain currency and help guide countries. And it is problematic if those estimates jump around because it in a way that doesn't correspond to changes in data, because countries get confused, or it undermines their country's uptake of their use. So that is definitely something they are worried about. I think it's also not just countries, but for certain other indicators, there is political scrutiny from people who provide funding. And so again, it can become political if estimates jump around without clear reasoning. So I think they have good reasons to be methodologically conservative, and they've just gone through a process of revising their methods and evidence base to produce these estimates for why they had one change from going from higher to lower. So I think there's now fairly high threshold for wanting to make another change within like a year, which is understandable. I think there's also at a kind of level beyond TB, as I understand it, ongoing discussion around the definitions of undernutrition, which may change. From my very limited for this kind of exercise, but again, maybe that would be the sort of if those things are changing, then maybe that would be a moment to revisit some of these approaches.
Thanks, Pete.
Thanks, Richard. There's a question from Jeffrey in the chat. Jeffrey, I don't know if you want to ask it. Otherwise, I think, Matt, you've answered it. Do you want to take that then, Matt?
It's just about, how you deal with confounding, really. So, the fact that undernutrition is highly prevalent in poor communities, which, who are also exposed to overcrowded living conditions and so on and so forth. And it just comes back to the previous point about the original research properly measuring and adjusting for potential confounders and analyzing the effect of nutritional status in a causal framework. Because in the end, the synthesis, the systematic review just relies on the original research. So we're kind of constrained in that sense.
And just to say, I suppose it also, one has to be consistent in the way the evidence is derived and the way it's applied. So if you took an unadjusted estimate and applied it multiply to multiple risk factors, then you in an inconsistent way, then you could go quite wrong.
Mm-hmm.
Thanks both. Florian.
Thank you very much, and a really fantastic session. And also thanks to Finn and Richard and others for organizing this session. In our effort to try to estimate individual level or independent effects of risk factors, we're often methodologically obviously adjusting for confounding and trying to eliminate concurrent effect of other factors. And I just wonder whether that limits our thinking within a causal framework, since we're not very well understanding how different risk factors act and interact towards the risk of developing TB. So an example for that is if you look at South Africa, if you look at, for instance, the prevalence survey data, where we see that if somebody is untreated living with HIV, then the risk is obviously very high to develop tuberculosis when infected. However, when now we're seeing that there's a very high prevalence now in HIV negative people, and then there's almost an emergence of all the other risk factors. So, which leads to the question: is HIV just trumping or making other risk factors less relevant, or is there some sort of a combined effect of risk factors? And especially when you talk about nutrition, there are so many consequences associated with reducing poor nutrition, so many benefits that go beyond potentially the pure biological or immunological effects. That's why I was wondering, is there any way or effort so far to understand how different risk factors interact with each other, and also how they might compound each other to increase risk beyond the effect of single risk factors? Thank you. Probably for Pete, a question.
I'm sure Matt will have something to say as well, particularly on the interaction. I mean, I was just thinking about the latter part of your point and the kind of fact that these things get bundled up with, the biology and the social things. And of course, it's very analogous, I think, to the kind of CD4 type stuff as well, where an HIV risk, I'm sure, includes social aspects as well as biological ones. For me, I guess, because both the CD4 relationships and these BMI relationships are kind of following this log linear relationship. They're somehow a little bit across a range, it's somehow a little bit self-controlling. So I'm not in any way trying to say that there aren't social risk factors as well, but I think the BMI link to me, because of that dose response, feels more more at the biological end of the spectrum. But I don't know if Matt agrees or disagrees, and whether he wants to comment on the interactions of different things, which sounds hard. And I don't know about any ongoing activities.
I think it's all just really interesting, isn't it? Because I think like over the last 30 years of kind of epidemiological research has been these factors associated with studies where you kind of generate estimates or odds ratios or relative risks through a kind of massive multivariable model. But I think that can warp all of our kind of estimates, and we don't really necessarily think through all these relationships you're describing. So I think alcohol use is another good example, because if you think about alcohol use as a risk factor for TB, alcohol use stops people from eating. It's that is the alcohol excess stops people eating. People get thiamine deficiency and they get thin, and they probably get TB because of the undernutrition, right? So undernutrition is like a mediating factor between alcohol use and TB risk. And I don't think that, I don't think the estimates of relative risk for alcohol use or nutrition kind of actually think through those relationships, because they're just derived from these kind of big models. So I think now that there's kind of increasing awareness of different methods for proper causal inference, hopefully that will cascade down into people at least more explicitly stating their causal assumptions about the way risk factors are associated. And I'm far from an expert, but I've read some things about like sequential PAFs. So if you've got multiple risk factors, are there ways of modeling what happens first if you take away smoking, then if you take away nutrition, then if you take away something else, or if you mix up the order? But the order will be defined by the causal framework that you have. So that's something to explore in the future as well, if we ever get funding and time.
Yeah, just very briefly on that again, I think it would be nice to see if it's possible to leverage the systematic reviews in the existing literature to understand at least to some extent how compounding combination of risk factors increase risk, and how maybe certain risk factors such as HIV might make other risk factors less or more important. And just to say that we're currently facing a similar question in a project that we're doing called the OpTB Treat project, which is a project we're just starting for 6 years, where we're looking at the factors determining whether people benefit from treatment or not. And that's exactly the same situation, because you have a lot of factors that can be compounded. And when you adjust for cofactors, you're not necessarily understanding how these factors interact to increase the risk that somebody is not benefiting from treatment. And I think we need to go beyond the old logistic regression idea to really understand how risk factors and combinations of risk factors work towards progression risk.
Yeah, and just to say, in the systematic review, we definitely observed that the risk of TB associated with undernutrition was lower than it was lower in people with HIV than it was in the general population, and that kind of makes sense, right? Because people with HIV have a kind of competing cause for immunodeficiency. I think what Nick has just put in the chat is very true as well, which
Nick,
is
comment.
Actually, I was just typing that this is not a criticism of this work, but more just that any observational causal inference will, there's always, it's causal inference conditional on assumptions, which is what's the case.
I see we are almost at time. Does anybody have a last question? Or maybe I can end with my provocative one, which I don't even need an answer for. But any last questions maybe before we do that?
Just on that we need more interventional studies addressing determinants, right? Like, because we as Nick says, we're extrapolating from observational data as to what would happen if we reduce smoking. But actually what we need to do is trials like rations and cressets and so on.
Absolutely. Maybe something to take away and think about then with the rest of our day is this all looks really complicated and there's clearly a lot going on here, and you can have everything from 10% of TB attributable to undernutrition to 25% or whatever, depending on the judgment and the value decisions that you make and all of that. So what do I, as somebody who doesn't have the time to think through all of this, what do I do? Do I just walk away and sort of take any PAFs that I see with a pinch of salt? Do I, would you say I should definitely use this one or that one? Or what do I do as a sort of somebody without a lot of time to think about it, but who wants to kind of use it to acknowledge the relative importance of different TB risk factors? What do I do?
I'll defer to you, Pete.
Well, I mean, in this case, I think it's about, the range of things we've seen. It's about being really explicit about the assumptions behind them and what they mean. I think that accounts for a lot of the difference.
Yeah, I think the numbers are less important than if they're consistent across risk factors, then the absolute numbers are less important. It's more like the patterns, isn't it? And it's really just about how you use them to prioritize things.
Fantastic. Thank you both. Lots to think about and some really interesting things, and nice to have a good discussion as well. With that, I will just close and thank everyone for joining, and look forward to hearing from Nick and Anna in a month's time. Thanks a lot. Cheers.
Thank you very much. Brilliant. Bye for now.